So what we talked about building in class was a simple item shop that could sell whatever type of item, whether that is fantasy, weapons, and items like here, or it could be a clothing store or a textbook store. And the idea with the application is that we've got a couple of items. We present them one at a time to the user to say, hey, would you like to buy this? And if they say yes, then we ask them how many they'd like to buy, and we can tabulate how much their order costs. So you spent time in class planning out this application, how you want to structure it with your different classes. And what I want to do in this video is just look at the shop class. So just thinking about a class that is responsible for orchestrating all of this logic. So it has all of the items, it knows about the items, it presents them one at a time to the user, and is able to handle the logic of figuring out whether the user wants to buy each item. So we will progressively improve on this and build better structured versions. But for now, what I just want to do is create a new class called shop. And since this shop is going to do a fair bit, I want to think about dividing up those chunks of logic into different methods. So we will have one public method that we can call from inside of program. So that's why it's important to make this access modifier public. And this will be responsible for kind of orchestrating all of the logic. So run all of the shop logic here. And what we want to do is think about the logic that needs to run and define those and create methods for those things. So here I can create a private method called display intro. And this is responsible for changing the color and displaying the title. Like in my GIF, it was items for gold and it had some formatting. So that would be the type of thing that runs here. And this can be private because we will just invoke it from inside of our run method. Other classes like program don't need to know anything about it. So we can continue chunking out our logic here into different methods. So we'll need a outro as well when they have finished running, like the thing where we say wait for a key press. So we can create another private method here for display outro. We probably are going to need to display that order total at different times. So I'm going to create a display order total method. And then we're also going to need a method that is responsible for selling the items. So let's create a private void sell item method here. If I zoom out so we can see all of these together, inside of run, we'll go ahead, we'll call the display intro. We will call sell item for however many items we have. After each one, we can display the order total. And then at the end, we can display an outro. So as always, when we're building an application that has multiple features, it is really important to chunk it and build small pieces, test it after each piece to make sure that you've got some working code before you move on to the next one. So for this, all I want to do is maybe get this display outro function working from run. So we're going to do something like we've done before, where we say write line, press any key to exit. Maybe we can preface this with saying, thanks for shopping, and do a read key at the end, which has the side effect of keeping the console open until the user presses a key. So these invocations of these console methods, these would work inside of here if I say console.writeLine, but as we've learned, we can also bring in the console class up at the top here. So we can bring in the static system.console class, and then when we use the word writeLine or the command read key, the compiler will know that we are talking about the console class here because we have brought in everything from the console class using this using statement. Okay, so we've got display outro. It just says, thanks for shopping, press any key to exit. We will call this from our run method here. And then back inside of program, what we can do is create a new shop. So we're constructing an instance here, and then we are able to call myshop.run, which kicks us over to this method, runs all of the logic, and at the end of that logic, which we haven't filled in yet, it will display the outro. So we can see, thank you for shopping, press any key to exit. Got that feature done, we can move on to the next one. So let's work on the intro. So this intro is just about displaying the title. So maybe we'll do right line, bunch of equal signs. And then I'm gonna copy this. Oops. Paste it in here, and I'm gonna put items for gold and delete some of these equal signs until I get it lining up. Maybe I'll add a couple equal signs here. And then cap this off at the bottom. And we've got our title. We can display intro. Check that that piece of logic is working. Great. We've got items for gold. Thanks for shopping. And now we need to fill out that centerpiece where we keep track of the order total and present each option one at a time to the user. So let's work on sell item then. So sell item, this we'll be able to refactor later, but let's use our new parameter knowledge that we picked up where we can define some things that we pass in here. And now inside of this method, when it's invoked, it is given an item name and a cost, and we can use those. So we can ask, would you like to buy this item? And then we can tell them it costs this much. So when we define these parameters, that means up here when we use it, we have to give it specific arguments. So we could say that we have a chipped sword and it costs 10.5. And here I'm using the decimal type inside of C#. If I hit F1, it pulls up the documentation page. And so we've generally stuck to floats in class, but the decimal class, the decimal type is really helpful when you need precision for things like currency. So I'm switching to using the decimal class here for this demo. Okay, so first thing we can do to test that this method works is just print out something like, would you like to buy item name for cost? And let's run this a second time too. Since this is a reusable chunk of code, we could say we've got a rusty shield for $12.25. So when we run it, we should hopefully see this prompt to us, this prompt to us, and then the outro at the end. So would you like to buy, I forgot the word the, or a, chopped sword, oh, that should be chipped sword, I'm making typos all over the place, for $10.50. Would you like to buy a rusty shield for $25.25? So would you like to buy a and for cost? And I wanted to fix this typo, chipped sword. Let's run it again, make sure I got those typos fixed before we move on to the next thing. So would you like to buy a or an chipped sword for $10.25? Same for Rusty Shield. So one thing that we can do in C# that's really useful is format numbers using a special syntax. So let me pull up the string interpolation page here. So this is that interpolation that we were doing where we start our string with a $, and then we're able to inject C# into our string. And there is, when we do this, a way to specify some formatting information for that whatever variable expression we put in here. So if I scroll down, this is the structure of that interpolation where we have an expression, we can specify some alignment, and then we can specify colon and a format string. And if I scroll down all the way to the bottom here, standard numeric format strings, these are helpful because they have different ways of formatting numbers. So for instance, if I have a colon, then the letter C, that formats things as currency. And if I specify like C3, that will give us how many decimal places, in this case 3, after the decimal that we want in our formatted currency. We've got a similar one, so we've got D, which is for decimal, and you can also specify how many digits, exponential, fixed point, general, number, percent. So we've got a lot of useful ones in here, but the one we want is currency. So the way that I specify that is here in my interpolation, I can say C2 for currency and 2 decimal places. And it uses my system's local setting to know that I want US dollar formatting here. So I'm getting 1050, 1225. Excellent. So we are asking them a question, but we are not capturing their response and doing anything with it. So what I want to do here is get their response. So do you want to buy this? I'm going to say you can put in Y or N. I will capture their response using readline. And as we've seen, we can also convert this to lowercase or convert it to uppercase, which means that we can make our check for their response case insensitive. So if they type in lowercase y or uppercase y here, this is going to still turn into uppercase y. And then what I can do is say if the response is equal to uppercase y, then we know they said yes. Otherwise, we know they said no. And so I can write line, oh well, you didn't want a, and then I'm gonna use string interpolation here, item name. And in here, we want to ask them how many they want of that. So let's just print that out. We won't worry about the logic yet of getting how many they would like, but we'll just say how many would you like? And see if this is working. So again, we built a feature, we want to test it. Would you like a chipped sword? Yes. Would you like a rusty shield? Try yes with a Y. How many would you like? So it looks like it's working. It's also good to test the other case. So type in something that's not a Y. So regardless of what we type here, it's giving us, oh, well, you didn't want that, which is perfect. One thing that we can do here is if we look at the string methods, so I'm hitting F1 to pull up my documentation again, and that is popping up this page. If I look down at the methods, there's a starts with method that allows us to specify a string or a character, and it will tell us true or false. Does that string start with this string or character that we give it? So instead of just checking whether it's Y, we could instead say response.starts with uppercase Y, which will allow us to type in yeah, yes, yup, and all of those will be selected. So, yup, how many would you like? Yeah, how many would you like? Okay, so now that we've got that working, let's actually ask how many and capture that response. So here, we're going to get the number. And once we have this, well, let's call this let's leave it as number response. So read line we've seen always gives us back a string. So when we want to use this, like here, we actually want a number. We want to know how many as an integer. That's where we reach for the convert class that we've seen before. So I can do int quantity equals convert to int 32 on that number response. And then here we would want to do the math and say, right line, okay. Let's do something where it says like the quantity times the name is going to be let's call this item total is the cost times the quantity. So we're going to say, okay, if they typed in 3, okay, 3 of the chip sword is going to be this total. And let's run it and test out this new feature. So would you like to buy a chip sword? Yep. How many would you like? Let's try 10. Okay, 10 is going to be $105 even. And again, we could format this to get it to show up nicely like we've got up here. So I'm going to use C2 to format this as a currency. Let's try it again. Would you like to buy it? Yeah. How many would you like? 5. That'll be $52.50. And then it goes on to ask me about the next item. One thing that we want to be careful of here is that the user can put in something that can crash our application. If I run this, would you like to buy a chip sword? Yes. How many would you like? Apple. Crashes. We're getting a system format exception that input string was not in the correct format, that convert.int32 does not know what to do with that string. What kind of number is Apple? So if I pull up the documentation page, again, I'm hitting F1 in Visual Studio to pop open my browser here, which will give me the documentation for the convert to int32 method. If I click on this and look at the documentation, we can see the exceptions that this method throws. So we can see it throws a format exception when that value does not consist of digits. And an overflow exception if the user typed in something that was smaller than the minimum value that an integer can hold or bigger than the maximum value that an integer can hold. And if we scroll down, we can see the structure for how we can catch those errors and prevent them from crashing our application. So here we've got this try block, which you put your code that can potentially cause errors within, and then you can have catch statements after it to catch the various errors and recover from them. So in our project, we can write our sort of unsafe code, our code that might crash, inside of a try statement. and we can then catch those specific errors and do something about them. So I put the name of the error here. So if I flip back to my browser, I can see we've got overflow exception and format exception. So if I catch the format exception here, we can write line, that wasn't a number, please try again. And as we've seen in other applications, we can use recursion to start this selling process again. So sell item, using the item name and cost, will start us back at the start of this method, prompting them again, do you want to buy this? How much do you want to buy? And as we're doing this recursion, like we did in class, we want to make sure that we return from this method to stop the rest of the code inside of this from executing after the recursion resolves. So here we're catching that format exception. We should also catch the overflow exception and do a similar thing. That number was too high or low. Please try again. So let's run it. Would you like to buy a chip sword? Let's say yes. Let's try apple. That wasn't a number. Please try again. Kicks us back to the start of that function, that method, and I can try again. Let's try a huge number. Number was too high. Please try again. Now we type in the right number and we get it printing out a valid amount at the end. With try-catch statements, you can also write a catch to catch all errors. So if we wanted to have a generic catch to get any reason why this could break, we could do that without specifying the error in parentheses next to the catch. In general, it is useful to catch those specific errors because they result from different things. So here we can tell them, like, you made a typo typing a number, please try that. Here we can tell them that that number, we don't support that number. So you're going to have to buy a smaller amount and give them more specific feedback about the type of error that occurred. All right, let's wrap this up with the last piece. Right now, we are presenting each item, but we are not accumulating that cost. So we have no way to know, here we know how much each purchase of like the chip sword costs, but we don't know if they bought the chip sword and the shield and they bought something else, what is their running total? So that's where we want to introduce a field. So we're going to want to have some information that is persistent across all of these methods. So we can increment that number in here with the item total, but we can access it in here and display our order total. So I'm going to fly up to the top of my class, create a new private field, private field of decimal, and let's call this our order total. And I'm going to create a constructor that initializes that order total to be 0. And the M here, that M suffix, we use to indicate that that number that we're typing is a decimal. So here, this constructor runs back in program when we say new shop. So 0, this order total is available as 0 as soon as we hit this run method. And we can use the order inside of display order total. So I could say write line, your current order total is, and then print out the order total, format it as a currency. And maybe add a little bit of formatting here. So just setting it off from the rest of the text in the application. And let's test it out. So after our intro, we will run our display order total, which shouldn't do anything interesting because we only have 0 here from our constructor. But once we know that function is working, we can start using it elsewhere. So we can see your current order total is $0. It's formatted correctly. Instead of placing it here, let's move it down after each item that we sell. And let's add a third one in here. Let's have a pot of gold. And we'll make this expensive. So we're going to display the order total after each of these. It should just print out 0 each time. So what we want to do is go into our sell item, so into this method. And when we know that they have purchased an item, so they've said yes, they have given us a valid number in terms of quantity, and we've got the total here. So we've said, here's the item cost times the quantity. Let's add that to our order total. So this is the increment assignment operator, which takes this number and adds it to order total. We've seen this before. It's the same thing as if I wrote something more verbose, like said, this is equal to order total plus the item total. These two are equivalent. So I'm going to use the shorter syntax here. And if we run it, would you like a chipped sword? Yes. How many would you like? 10. Okay. 105. And we've got 105 for our current order total. Let's get a rusty shield. Let's get one of them. That's going to be 1225. And then we can see our order total went up. Let's grab a couple pots of gold, 3,000, and our order total went up again. That's basically it. We've got a basic skeleton for our shop class. We will be able to upgrade this and makes it more flexible, use some new programming skills as we continue to build this. Like we'll be able to take these items and move them into an item class as opposed to using them as parameters. But this gives us a good skeleton to build from, to iterate from, and lets us practice some of our new skills. I'm just going to take a second to add some more formatting into this to wrap up this video. So let's add some white space between all of these, and let's add some white space here. So that should help space out the elements of our user interface. Yes, 10, and then our order total shows up here. Yes, 2, and our order total shows up again. I think I just also want to highlight the order total. So I think I'm going to come down here and refactor this to set the foreground color to be a green color for money. Console color dot green. Whoops. Console color, not console. Console. But as we also saw in class today, if I do this, things are going to show up in their default color as we run through the first time. But then as soon as we get to the first order, this shows up in green and everything else stays green. So as we are formatting the color in our application, it's useful to reset the color after you're done. So we could say console color dot white here, and that would set our text color back to white. Or we can write our code even more flexibly and say previous color is equal to the foreground color, and then our foreground color is equal to that previous color. So we're caching that foreground color before we change it, and then after we're done, we're resetting it to whatever the previous color was. So this should work. Shows up in green, the rest of the text goes back to white. And this also works if we decide like, maybe we want our default color for our application to be something else. Like we could say the foreground color is equal to console color dot dark. Well, actually, we don't want a dark color since it's white. It's a black background. Just for demo purposes, let's just say that it's cyan. So now the application shows up in cyan, and our order gets called out in a different color. But because we used a variable to cache the foreground color, we are able to reset it back to that cyan as opposed to just always setting it back to white. So it's more flexible the way we've written it now. Okay, so that's it. That's a basic skeleton of a shop. This will help you practice methods and parameters, and will also help you practice try catch. So make sure you've got this functioning and working. You can go ahead and add more styling to this. Like this is a very simple version of the shop with not a lot of color happening. But if I bring up that GIF that I had before, you can format things more. Like you could have each item take another parameter for the color to set that color if you wanted to add some more user interface, a nicer user interface to your application. So that's it for this version. We'll keep building the shop later.